Okay, so good morning to everyone. Good morning to you again, Dr. Chikaore. I saw that you've already placed your slides, but I'll start with the introductions, and then I'll give you the platform to go ahead with the session. Can I just get an indication if all the people that are in the session can hear me, just by the raise of thumbs up? Okay, thank you so much. Welcome to today's session. Today's session is titled Thesis Writing in the Natural Sciences. And my name is Koketso Pila, and I will be your moderator for today's session. Firstly, let me notify you that this session is being recorded, and I have already clicked on the recording button. And I would also like to thank everybody for taking your time to join us today in this workshop. And most importantly, I would like to thank Dr. Tichaona Chikore for his effort with preparing and giving this presentation today. Before I can officially introduce Dr. Chikore to you, please allow me to go over some housekeeping rules and some of the important information that we need to take note of. So if you do have questions during the presentation, please raise your hand. If you would like to speak, alternatively, you can type your question on the chat box. I will then indicate to Dr. Chikore to address your question. And as I've already mentioned, that this session is being recorded, and the recording as well as the presentation slides will be uploaded on our Moodle community by the end of the week. And also there is a feedback survey that will be posted on the chat. Please, can you take some time to complete the feedback survey for us to gain some insights on whether this workshop was useful and how we can improve in the future. And on the feedback survey, you can also suggest some of the topics that you would want us to cover and address, and we will do so. And just to announce to everybody, sorry, that we have a 3-minute thesis competition that will be taking place on Friday, the 29th of August. We will be sending out emails to the students to register to become online audience. So please look out for that email and then register to be one of the online audience. There are games to be played, and there are also prizes to be won. Also, the online audience will get the opportunity to win some prizes. So, and you'll also get to engage with some of the PhD students as they present their work. Without further ado, I will then introduce to you Dr. Tichaona Chikore, who will be presenting this workshop today. So Dr. Tichaona Chikore, is a postdoctoral research fellow at the University of Johannesburg with Prof. Farai Nyabaza, supervising MSc, PhD, and honors candidates. His scholarship interrogates nonlinear dynamical systems, stochastic and deterministic modeling, quantitative finance, biomathematics, and computational data analysis with translational outputs in criminometrics, epistemological modeling, and policy analytics. He has spearheaded capacity building programs such as the Applied Mathematics Research School in Malawi. I will then hand over to Dr. Chikore to take us through today's presentation. Thank you.
Thank you,
Over to you,
Koketso.
Dr. Chikore.
Can you hear me? Can you confirm that you can hear me?
Yes, we can hear you clearly.
Thank you very, very much. Thank you very much, everybody who has managed to come to this presentation. My name is Teacher. Sometimes if you say Dr. Chikore, I forget. But if you call me Teacher, then I'll remember. Everybody calls me Teacher. Thank you so, so much. Um, you will help me, Koketso, if there are any questions, any things that are matters that arise, but I'll try my maximum possible best to be very clear. I want to thank the Department of Mathematics and Applied Mathematics and the HOD, Prof. Farai Nyabaza, and the Deputy HODs, the 3 Deputy HODs, and also the Research Capacity Development I am here because those people made it possible for me to be here. And then I want to thank my colleagues, the students that I supervise, and everybody in our mathematical modeling research group who has managed to make it here. Thank you so much to those in the UK. We thank you so much also for being here. So I'm not going to spend time introducing myself because that has been done. So let me move on. What we are going to do is we are going to look at how to write the thesis in natural sciences, but we are not going to do it the usual introduction, objectives, literature review kind of way. We are going to explore it in a different way. And I have got learned colleagues here that can help me whenever also I'm stuck with some questions that you guys might bring up. So if ever I happen to be too fast, let me know. I'm sure that you can hear me clearly, and I'm also going to try to be very, very clear in my explanations. Thank you very much, everybody, for coming. Thank you very much for joining us. Now I can start. Now, in order for me to get started, it's important to tell you that I will have the introduction and objectives of this talk, followed by you, the candidate, as a natural science researcher, and then the supervisor-student relationship in science, then followed by the timing and planning. So as you can see, 2 and 3, they are looking at the candidate himself. And then now we start at 4 concerning the writing of the thesis. So that is the second part. So timing and planning for experiments and writing, because some people are working in the laboratory. So for those of colleagues that are from the maths department, there are people that actually do actual experiments in the laboratory. So we also refer to experiments as all that, laboratory experiments, desk research, and everything. And then, so the timing and planning, and then we need to understand the state of mind of the person that is writing. So science writing challenges, then structuring the scientific thesis, which is something that has been discussed extensively. I know that the RCD has got a person that can come and talk about the introduction in its fullness, something that I'm not going to do, or the literature review in its fullness. I have seen such emails inviting us to attend. So guys, if you are invited by the RCD to come and attend these, please do attend, because these are now specialist topics whereby how to write a literature review, and you need to understand that. This is going to be, so the structuring of the scientific thesis, which starts with the introduction and then the literature review, followed by the methodology and analytical clarity and the results. So when I say results, at a certain time, I will be talking about, when I say data, I'll be talking about the results, but I'll try to be very, very clear in my explanation. So sometimes, yes, data really means results, because to people in chemistry, geochemistry and stuff like that, that will be the data and the data will be the results. So we need to understand that use of words is just a matter of semantics. Then we then have a discussion and conclusion, scientific interpretation. Our thesis is finished. And in my case, as a presenter, I would then try to put everything together. I want to try and bring everything together, the scientist and his mindset, or the scientist and her mindset. And that's what we are going to do. So we put everything together, and then we've got this. So what are the objectives of this talk? Why are we having this talk? The workshop goal is to try and integrate thesis structure with mindset for scientific research. We are scientists, be it here in mathematics, be it here in agriculture, be it here in chemistry, in biology. We are scientists. And our focus is on natural sciences, and we work with field work, simulations, data analysis, experiments, and the expected outcomes for this talk is to have a clear understanding of thesis sections in natural sciences, and also develop an awareness of behaviors and strategies for resilience and productivity. So writing a thesis, like my prof always says, it's telling a story. It's your scientific story. So writing a thesis in the natural sciences is both intellectual and practical. You have to be part of it. So students will learn not only what to write, but how to manage the the data that you're going to be working with, the experiments that you're conducting in the laboratory, and then your own workflow and mindset. Like I said, you are telling a story. Now, this is all about knowledge, sharing knowledge. And it brings us to this philosophical discipline of science of epistemology. So now, epistemology is the theory of knowledge. Like, how do we know what we know? Because we know something, but how do we get to know it? So you are going to be working, you are going to be digging here and there, going through other people's work, finding values, this and that. You must be able to reflect on how your data and evidence support your claims. So you are going to come up with this big thing that says, there is this thing called the force of gravity. How do you support that particular claim? So as you make those claims, there are also limitations. So you need to consider the limitations of your methods and the certainty of your conclusions. Because remember, whatever you are working on, if you share it out there, it has got the impact to change somebody's world for better or for worse. So imagine in pharmacology, you make this drug, you come up with these conclusions that we've got a cure for HIV/AIDS, and then some people actually end up following what you are saying. But it's not based on understanding the limits of your methods, and then we get some side effects. So we need to dwell on epistemology to understand how we know what to know, and the questions that we need to ask ourselves as we write this thesis. We are going to say, what constitutes valid knowledge in my field? So what is it that I am questing for? What am I after? What am I trying to show to the world? All right, that is the first thing. And then as you try to think about that, you also now are burdened with the question of how do I justify my conclusions based on the evidence? I've got a story. I did something because I am in a quest for knowledge and I did something in order for me to get that knowledge. But now I've got these conclusions, but how do I justify them based on the existing evidence that we've got? But again, like we said earlier on, you need to know that there are limitations concerning your method and assumptions. So what are the inherent assumptions and uncertainties in my experimental design? When you come to that good conclusion, groundbreaking conclusion, what are some of the limitations that you are actually faced with? So let's look at part one. So this is about knowledge. I'm talking about scientific knowledge to say, how do we know what we know? Obviously, people are going to tinker with this, have that experiment. But again, how do you put everything together? So these are questions that you need to ask yourself in general to say, on this journey that I'm going to embark on, how am I going to handle all this that I'm going to encounter? What constitutes valid knowledge in my field? How do I justify my conclusions based on the evidence? What are the inherent uncertainties or assumptions in my experimental design? So let's talk about the candidate as a natural science researcher. You are the one who wants to write the thesis, but who are you? Or what must you be? Or who should you be? So that's what we want to discuss. But the first thing now is, let's approach this from a philosophical mindset on the project. This is your work. So I would say you are somebody who owns the project. This is more than task management. Technical researcher, a person who knows how to move things around. This is beyond that. This is you owning this. It's about epistemic responsibility for your work's integrity, to be able to have the true facts to defend what you are coming up with. And that now requires a new character, attention to detail. So as you do whatever you do, you need to have meticulous laboratory notes and data accuracy. And these are the foundations of methodological rigor. You must give us work that we can reproduce, work that we can verify. We need that. So paying attention to detail is going to ensure that we are able to reproduce your work. We are able to verify your work. And this brings us to one person called Karl Popper in the philosophy of science, who talks about falsifiability of any scientific assertion. If you say, I have found this in science, then give us a chance to prove you wrong. Let us be able to reproduce, let us your results, let us be able to verify your results. And I will tell you of another person in the philosophy of science called Thomas Kuhn. Thomas Kuhn says, look, science is normal. Every day you try to write this paper, you write about HIV/AIDS, then the next time you're using your SIR model, or you go into the lab, you try to change this color, and then you see, okay, what happens if we use purple? What happens if we use pink? It's a normal thing that we do every day. Sometimes we get things right. Sometimes, most of the times actually, we get things wrong, because if we could get good results from the first onset, then we're not going to struggle with anything. So we need to be very persistent, and persistence goes with failed experiments and acknowledging them as not as setbacks, but as a form of knowledge. Our failure is a form of knowledge. And this attitude embodies the principle of falsifiability and builds resilience. If it doesn't work today, it will work tomorrow. And you keep on pushing in that direction. Recently, we had a presentation from Prof. Farai, and he told us about having a curious and analytical thinking mind. And these are the virtues that drive scientific inquiry, helping you identify anomalies and contribute to your scientific paradigm. So what you are then doing is you are questioning with the big question, why? Why are things working this way? I'm not so sure how true the story is, but legend has it that Isaac Newton was sitting under an apple tree, and then an apple fell on top of his head, and then he questioned, why did it just fall all of a sudden? They say that's how he discovered gravity. Again, I put it on record that I am not so sure about this story. But that curiosity, that analytical thinking, it helps you move from being a standard cramer person who knows what to do, a technical researcher who knows how to put pieces together to say, if I'm writing this paper, I need an introduction methodology, and then I need a conclusion and discussion, and that's it. You become this person like, so why was this said in this particular way? Why? Because when you're writing your thesis, every step is challenged. And being able to do that, it makes you this person that can defend your work. So that is one part. We are going to talk about all these things. Then the last thing that we now need to do, because we've got the results, we've collected our results, we now need to write, to tell our story. You know, when you know what you know, but you don't know how to communicate it, then that becomes a problem. And that's the thesis. I always say to my candidates for PhD and for masters, I say, look, unfortunately, in your thesis, there is no room for a voice note where you start explaining what you meant. When they mark your thesis, they are marking everything you did over 4 years. You fail to write your story of 4 years, then unfortunately, things don't go your way. So you need now to balance between balance writing and your results gathering. Your work is not complete until it is communicated. Writing translates your findings into a coherent narrative, making it part of the public body of knowledge. So that's what we have got. But as we do that, again, we are mandated with some responsibility. We are going to put together some results. We are going to write our story. But again, as we do that, the burden of being socially and ethically responsible is upon us. So as a researcher, you're not just a data collector. You're not somebody who is gathering results. Remember, I said when I say data, sometimes I actually refer to the results, not to the numbers. So you are not just going around collecting results in a laboratory, like collecting results and then putting them together and then say, this is what we are getting. You are a custodian of knowledge, and it means understanding the ethical implications of your work, starting with data privacy. That's why now in certain research areas, you have to get ethical clearance, but also it involves being transparent and avoiding practices that could be misleading, like what is known as p-hacking. And I'm going to just give you what characterizes p-hacking, because your role is to build trust and contribute to the common good. So mostly people will formulate a hypothesis before they collect the results to say, I'm looking at this situation and I think that all criminals operate at night. But what gives you that idea before you've collected results, before you've embarked on this research? You already have formulated a hypothesis, and that hypothesis leads you to seeking validation. So, in other words, you are going to look for a pattern that meets your hypothesis. In statistics, it will be you are looking for the standard p less than 0.05 threshold for statistical significance. So that becomes a problem. And we call it p-hacking. It contributes to p-hacking. It's a common p-hacking techniques include, number one, stopping data collection early. In other words, you collect a bit of data, say you've sent people out there in the field and they're getting real-time data. Then you start your analysis as early as is possible before all the data has been brought in. So running tests on the data that as it is being collected and stopping once a significant result is found, even if the predetermined sample size hasn't been met. You're going to get and justify what you want because already you've formulated the hypothesis before collecting results. And that's dangerous and that's not allowed in thesis writing. Or cherry picking variables, measuring many different outcomes, but only reporting the ones that show a significant effect. Your thesis, remember, shall be in the library for future generations that are going to come in 2099 when we are all gone. And they are going to pick up that, but why did they stop here? Why didn't they choose the other values? Are the people from the 2020s different from the people in the 2099s? Because now the results are a little bit different, only because you sort of like cherry picked your variables. Another thing is removing outliers, like data points that are inconvenient to the desired results, and outliers, and also changing the analysis plan, trying different statistical tests or ways of slicing the data until you yield the results that you want. That's unethical and that is not allowed as you write your thesis. Now, let's look at you again as the candidate. Now we've burdened you with social and ethical responsibility. And let's look at your supervisor relationship, supervisor student relationship in science. I have had one of the best relationships. I think, let me just say, mine goes beyond supervisor, it's department student relationship in science. So I think I'm going to talk from a position of somebody who has been blessed enough to have very fruitful and very meaningful, long lasting relationships. Now, one thing you need to know is that I can use the words fruitful, meaningful, and all other fancy words, but what we need to understand is that this relationship is a shared pursuit of scientific truth, not just a professional one. Yes, bring the department, yes, bring any other thing, but what we are actually looking for, the both of us, me and the supervisor, myself and the supervisor, is pursuit of scientific truth beyond being professional. So let's look at the supervisor as a Socratic guide, because we're talking about scientific truth. So we have to talk about Socratic guide to say the role of the supervisor is to mentor you by asking probing questions, not by giving all the answers. I remember one student was like, teacher, if you know what I must do, why don't you just tell me? And I'm like, my role as a Socratic guide is to mentor you by probing questions, not by giving all the answers, because I can write a second thesis if you want me to write it. So what is the purpose of this role of the supervisor is to help you develop epistemic independence, the ability to think critically and justify your own scientific beliefs, because you are on your own person. So when we say epistemic, it relates to knowledge, and independence, it relates to self-reliance. So you are going to embark on this journey with guidance, but it's your journey, it's your story. So what we then need is, you need to have this ability to justify your own scientific beliefs and claims without relying on authority of your supervisors or others. You have to stand on your own. So that is in its own form the greatness of what UJ is always doing year in, year out, equipping students with this form of ability just to be themselves. And we've got quite a number of people that appear on national televisions or national forums to discuss science, but having this background to say, I was supervised, but now I can justify my own scientific beliefs. Well, it takes time. It takes you as a student, as a thesis writer, to be able to have as much information as is possible concerning your subject matter so that you become an expert. But there are other experts ahead of you who they go by the name of your supervisors. So the supervisors as Socratic guides, they help you to make you stand on your own. So when you have epistemic independence, when you have got now self-reliance, you can now critically evaluate evidence. You don't just accept data at face value, you question its source, its accuracy, and the methods used to collect it. I remember when we used to talk about crime, because when I did my PhD, I was actually looking at the philosophy of how crime dynamics propagate. And one of the things that I picked up is there was a certain time when I could stand and defend using the various theorems, the theories that are found in criminology, to say, look, according to the routine activity theory, this is not a crime. Yes, it's a crime, something happened, but according to RAT, this is not a crime, because now I just don't accept, by then, I didn't just accept things at face value. I had to question the source of the information. Even if you receive certain data, even in terms of numbers, you can then say, but why is it that the death rate is 5.4%? Because you know very well that under normal circumstances, the death rate is 0.3%. So you are this person who is not just taking everything as it comes. So that becomes the you that we want. And then in that respect, you end up being able to formulate your own hypothesis. So you move beyond simply testing someone else's ideas to developing your own research questions. So you end up having your own research questions. And that's the kind of person holding a thesis at the end of 2 years of master's, at the end of 4 years of PhD, or 6 years if you're studying part-time, to say, look, I have formulated my own hypothesis. I have learned from other people's ideas, but I managed also to develop my own research questions. Does that mean that you don't need your supervisor? No, that's not what I'm saying. I'm saying that the supervisor will help you to stand and defend your conclusions, and you can articulate the reasoning behind your findings and anticipate counter arguments, even if they challenge your own work. So that can happen, that you actually look at everything up to the point of I don't know, because by then you would have exhausted everything that you know, and then the question is still standing and you do not have an answer. And by that time you will be mature enough to say, look, I will go and have a look at this. So you and your supervisor, you have got a joint commitment to integrity. When we look at your thesis, it is going to be written Chaona Chikore, supervised by Prof. Farai Nyabaza and Prof. Jane White. It's a joint commitment to integrity. We open that thesis. We must understand, as anybody from VITS, from UCT, from a university in America, as they open that thesis, we are both custodians of that particular research. So this relationship is a shared responsibility for ethical conduct, accurate data, and proper protocols, which are essential for trustworthy science. Remember, we are saying, how do you write a thesis in natural science? And in natural sciences, it's trustworthy science. So you will find that the thesis is the final product of of the shared responsibility between you and the supervisor. And your method section and the results chapter are a testament to your shared commitment to integrity. The methodology, the results, your shared commitment to integrity. You didn't make things up for the sake of graduation. Congratulations, you made it. But as we look at your thesis, we have got questions, serious questions. How did you even get this graph that is here? We realize that you cropped it from somebody's work. Now, can you see that not only are you putting your supervisor at risk, because sometimes I will take, give you a scenario. A supervisor will go through your introduction, marks you correct, and say, this is fine. Then you go again the next day to your thesis, you feel like, I can do better with this introduction. The very same introduction that has been updated by the supervisor. And then now you update, you put some image that you cropped from somebody's work. And then since the rest of the work was said is fine, then everything is still fine. The next time when the supervisor is looking at your thesis, do you think that they are going to start at the introduction? No, they are moving on. We looked at the introduction, but somebody was not transparent enough to say, this is what I did. And unfortunately, that accurate data presentation, that proper citation of figures that were extracted from other people's work, if and it's still there, if it is still there, but the reporting of protocols are not anymore transparent. So you are a joint team with a joint commitment to integrity. Your supervisor will be like, but why did you use this work from somebody? Now they don't talk about you alone because you are working with your supervisor. So it's a fiduciary relationship, a high trust relationship. The supervisor is ethically obligated to act in your best intellectual interests, and you are obligated to be very, very transparent. And this trust is the foundation for productive collaboration. All right. So we have talked about you. We said we are after knowledge. How do we know what we know? And then we talked about you now as the candidate for writing in natural sciences. And now, how do you write in natural sciences, which is actually the subject of this whole presentation? Scientific research writing. Now, scientific research writing, if there are questions, I will be informed by Kokeso, so let me keep on pushing. So in scientific writing, the first thing that the university, if I zone it around the University of Johannesburg and many other universities that I know, mostly for PhD, we give you 4 years. For masters, we give you 2 years. Part-time, they push to 3 years for masters and then 6 years for PhD. That is in general, but I'm not saying this is the blanket thing. So those 4 years, they have to be properly timed and planned for so that you achieve what you want to achieve. So timing and planning for be it experiments, be it you are doing desk research to look for new information, and then the writing itself. From my own experience, I started writing a thesis in the December, because mostly registration is in January. So in the December of my second year, I started writing the thesis looking into my third year. That's what I did according to my own timing and the advice of my supervisors. And like we said, you're telling your own story and it's your own journey. You are going to have your own experience. So don't say now it's December and next year I'm doing my third year. Let me start writing. So you still need to do this at the advisement of your supervisors. So timing and planning for experiments and writing. Remember I said experiments means every other thing that you do either in the laboratory, sitting on your desk, looking for new knowledge and gathering every other results that parameter estimation and stuff like that. To me, everything that you do under that banner is an experiment. This is writing. What is it made up of? So this is a long-term iterative process, all right? And it starts with your proposal being approved. That's now your journey as a master's student. That's now your journey as a PhD student. So your proposal is approved. Even at honors level, you go to your supervisor and say, my topic is this, 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 this. I want to be working on that. And then data collection or lab experiments, when you go, you research, desk research, where you just look for work done by others. Then you look for avenues in methodology and stuff like that. And after that, you analyze everything that you've gathered, your results, analysis, your simulations, you look at that. Then once that is done, you've got everything you need, then you start drafting your chapters. Like I said, towards the third year, I felt that I was well ready enough to write my thesis and submit maybe at the end of the third year, so that my fourth year I've got time to fix some other things that might arise, because things will always arise. So now this long-term iterative process, you must understand that sometimes things might go your way. Things might not go your way. You can have equipment issues if you're working in the laboratory, weather delays, failed trials. Sometimes you look for data, you don't find it anywhere. That is part of the journey. It all happens. And it's part of thesis writing. So what then becomes critical? Time management. Time management is critical, and I recommend using Gantt charts or project management software. So progress is often nonlinear in experimental research, and planning reduces stress. Do you know that there are people that are always shooting at everything and anything when they are writing? First of all, their PhD journey is not so organized, to the extent that as they put things together, is they have this idea in their head to say, this is my topic and I'm trying to look for a methodology. They don't know when they are going to be doing what. So by the end of the year, you realize you were running very fast, but at the very same spot, you feels like you did nothing. So I thought of the Gantt chart, where you can actually, so the one that is available is actually available at Microsoft. You can actually, when we share these slides, you can also have a look at this link that I've provided here, various templates for the Gantt charts. Because all you need is to have your project name, and then the date the task begins, and then the number of days the task will be, it will take to complete that task. To say, I'm going to be looking at bifurcation. Then I'm going to write about bifurcation according to what I've gathered. And then when I'm going to start this, when am I going to end this? And then you put everything together. Did I meet the target? What is wrong? So that's one of the things. Even when we supervise, we write to our students, give us your roster for August. From 1 August to 31 August, what are you going to be doing? So we are sort of like forcing them into this Gantt chart ideology, so that at least you've got proper time management. All right. So you are ready to write. Your time is on point. Everything is there. Let's look at the state of your mind. Science writing challenges. Number 1, frustration with failed experiments, or when you can't get what you are looking for. Because some people don't use experiments. Some people actually have to dig in to see work that was done by the others, to look at global stability. You try that thing until you realize that it's not stable. The global stability is not stabilizing anyway. You are trying. So you've got frustration with failed experiments or methods, and failures are part of falsification and scientific progress. So you need to learn to present failure as valuable evidence, because sometimes certain failures are not because you can't. Can you imagine how long they've been trying to make the HIV/AIDS drug, the one that can cure and end it all? but they've been failing. But they didn't report that those failures as failures, but like, we are making progress. Now we've got a drug that can do that, but with these side effects, da 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 da. They have got all that. So when you try and look for steady states, you try and look for a change in the color of your chemical, but it's not happening. You need to present those failures as valuable evidence rather than as wasted effort. Also, you are going to get so much data. I remember when I was working on something, and then I got this data and then this data. Sometimes the data looks like there is no relationship at all. And you now need to tell yourself in your mind, because we're talking about the state of mind of the scientific, natural science writer, to say, let me look at this from the point of the paradigms, the scientific paradigm that we are operating under. Like what Thomas Kuhn said, he said, the science moves in paradigm. And when there is a scientific revolution, that's when things change. So like right now, we are living in the world of AI. It means that somewhere, somehow, the way they were doing things in the 90s in science is not the same way that we are doing things now. So don't be overwhelmed by complex data science, but rather link what complex data sets, but rather link what you are finding, the results that you are finding, link them to the paradigm, link them to the now that we are living in science. So don't look at just the numbers and choosing what counts as evidence and how it fits into the existing scientific conversation. What are we talking about right now for IR? And sometimes certain data applies, sometimes certain data doesn't apply. And the relevance of such data is important. And also, like Prof mentioned the other time in his presentation, the same presentation I referred to the other time, the imposter syndrome in competitive fields. So science is collective, not the work of solitary geniuses. We know when we talk about Albert Einstein, when we talk about Isaac Newton, it would look as if he invented calculus by himself, of which it is debatable. But there are people like Leibniz that were there. So there was this exchange of information that was taking place. So writing a thesis is not about proving genius, but contributing meaningfully to a shared knowledge project. Find your space in the bigger body of science. And first of all, you respect those that found some things before you, and also you fit in there. So it is collective, it is messy, it is pluralistic. It means that we go together, we work as a team, we collaborate. All right. So the state of mind of a science writer, it's got common struggles, and I've listed them, and we need to have strategies to combat these struggles. Number one, you need to break tasks into small goals, because every day we go to the lab, we do this, we tinker with this, we tinker with that. Scientific inquiry itself proceeds in small, testable steps, reinforcing the idea that knowledge building is gradual, it's not instantaneous. So you need to do this smaller thing today, you do the next smaller thing tomorrow, you try to put them together. So you need to go and reflect on successes and progress. Because normal science, which is what was said by Thomas Kuhn, to say every day is a normal day until a scientific revolution, something that changes the paradigm, happens. People talk about Archimedes when he had a problem with the king and gold, and then he jumped into the bathwater, and then it showed the issue and the theory of displacement, right? So then he found something. But otherwise, every other day, you will be bothered by the same problem. HIV/AIDS, we need a cure until a cure is found. So no, that's normal science, everyday living, small goals, and cumulative work within a paradigm rather than revolutionary breakthroughs at every moment. Imagine if today we can say, now the humans can fly. Today we have found a cure for HIV/AIDS. And also, do you think that is even possible? For how many years now? So there are no revolutionary breakthroughs at every moment. Science grows not only through paradigm shifts, but also through the daily discipline of researchers. We need to collaborate. We need to work together. We need writing groups. Scientific knowledge is never purely individual, but it is constructed. In the Department of Mathematics at UJ and Applied Maths, we actually have research groups that actually showcase their work now and again. Led by Prof. Schroe. And so we know we belong to those groups because we know that scientific knowledge is never purely individual. That's one thing that we need to know. We belong to a community. We've got our PhD students there, we've got our master's students, they're showcasing their work. So science and thesis writing are collaborative activities strengthened by feedback, dialogue, and shared struggles. And sometimes you learn that, oh no, we were barking. That's okay. Barking is good. Bark at the wrong tree. Now the tree is bad. We need a new tree. So that's what you do. You discover things as you share with other colleagues to say, this is what I'm doing, and you are going to challenge the myth of solitary genius to say, I'm Isaac Newton, I'm going to discover how to do this. People think that Elon Musk works alone. Elon Musk doesn't work alone. He has got a group of people that he works with, but well, he's the brand, at least according to my own opinion, to say he's the face of what they are doing, but they work together as a group. Now, your mind is sorted, but how do you write? Clarity is the courtesy of scholars. The author is particularly unknown. Clarity is the courtesy of scholars. The scholar has got the responsibility to be as clear as possible. One thing that I want is what was said by Marcus. So Marcus said, we should not write so that it is possible for our readers to understand us. I read this twice. I said, okay, I'm not supposed to write so that people understand me. What must I do? But rather, so that it is impossible for them to misunderstand us. We don't want to give them the opportunity to misunderstand. So that's the kind of writing. Like I said, there is no room for voice notes to say, so what I meant there, footnotes, voice notes, there is no room for that. No one must misunderstand you if you write properly. So natural sciences rely heavily on the presentation, and structure reduces cognitive load and makes results interpretable for examiners and readers. So that's the essence of a good thesis. And a well-structured thesis acknowledges this by not only presenting results or data, but also situating them in the framework of existing theories and assumptions. Where do you fit in as a scientist of 4 years at UJ? After your 4 years is done, who are you? Where do we define you? And where do you fit in? So you need to have a well-structured thesis. And structure helps the reader see how the data fits into, or the results fit into, or challenge the current paradigm. So obviously, if you hear the story of Albert Einstein, having read about how Isaac Newton was giving us these laws of physics, and then Albert Einstein comes with relativity to extend the laws that were given by Isaac Newton. So you realize now that he got a place for himself, and he actually challenged the paradigm that was there of the Newtonian physics. So you need clear data presentation to ensure that findings are not logged inside the researcher's mind, but accessible to peers. So there are people that know stuff, very good stuff, but can't just say it. So unfortunately, you will never have a wedding or even hear of wedding bells. Well, you hear other people's wedding bells. If you like someone and you lock it into your mind and never say it, or start acting around, going around, showing signs, but that's not clear data presentation. These things are in your mind. They are just locked inside the researcher's mind, but not accessible to peers. I remember I did that, not the wedding thing, but I mean, when we were in a group collabo, and I had my idea that from what we are trying to do, the predator prey model was the best. But it remained on my mind. People were debating, trying to look for methodology until somebody said, maybe we just need to try the predator prey. And I'm here. I'm looking at it. I'm like, the predator prey is the only thing that can work here much, much better than anything. So ideas are locked in your mind. What you want to say is locked in your mind and it's not on paper. And again, we will never, as examiners now, we will never know that there are some things locked on your mind there. So from a philosophical standpoint, science advances through dialogue and critique and enabled by transparent, interpretable results. You need people, you need your supervisors, you need everybody, every step of the way. So there are some people when they start writing their thesis, remember this is like your third year, fourth year of studying, you feel like now you're in charge because of course you're in charge. We said you must be able to defend your findings, formulate your own hypothesis. We said all those things. But again, you still need people and guidance, dialogue, critique, and you need to be very transparent and give us interpretable results. Now, let's write our introduction. I'm not going to zoom into the nuggets of the introduction, but I'll just in general present what an introduction must be, and the same shall be true for the methodology and the literature review. So you need to say, there are 4 main elements that are needed in an introduction. I learned this to say what has been done, because whatever has been done is the one thing that ignited your curiosity earlier on, that mentioned earlier on. Background that culminates to what has been done. And then where do you fit in? What is the gap in the literature? So it means that there is need for extensive reading. You cannot just say, because I read 2 papers that were not talking about quantile regression, so because of that, now I'm now introducing quantile regression. You read 2 papers. So it's extensive reading. I think when I started with PhD, doing a PhD, I was told that, look, you guys, you are now technical researchers. When we were doing PhD, we would spend a year just reading, opening this and that and that. And I started reading. You can't defend what is existing if you don't know what it is that exists in the first place. Or stand and say, I've got a gap in literature simply because you read 2 papers and you feel like that's enough. This is a gap. And then until we bring 1,000 papers that are going to tell you that all this has been done. So what do you use? Your Google Scholar. You go and search on Google Scholar to say, I'm trying to research on malaria in Burundi. And then you look at malaria in Burundi, then you find that there are like 500 papers. So maybe a lot of work has been done. Because once you find your gap in literature, the next question is like, so what do you want to do? You now formulate your objectives. And then your methodology, how do you intend to do that? So when we talk about finding a contribution to science, it can be in 2 forms. Number 1, you're going to get new results completely, which is a good thing, or you are going to introduce a new methodology, but leading to the same results. So those are 2 forms of the gap that you can say, look, I want to look at hearing problems, but I'm going to use a mathematical model. But in this case, I'm going to use numerical methods, non-standard finite difference method, because the work that was done by so and so simply used ordinary differential equations. And you try to reach to the same result, to get to the same results, and now that becomes a contribution. So how do you intend to do it? That may be different from different to previous studies, and that is your contribution. There must be a contribution. There are no expectations much concerning contribution at master's level or honors level, but at PhD level, as you write your proposal, they are going to ask you, what is your contribution to the body of knowledge? So now your introduction is done. Like I said, I'm going to summarize it. I'm now going to move on to the literature review. Now, the literature review is very interesting. There is this thing called the theory ladenness of observation. So in literature review, in the scientific context, we are trying to synthesize studies and highlight patterns and gaps. So the idea is that no study stands alone, but otherwise it is interpreted against existing bodies of work. Because if that were the case, I was going to tell you today, let me tell you now, I have discovered that humans can fly. So there is no literature to back that up. It's just me and my ideas that are locked in my mind, but now I'm releasing them to you. So there is no study that stands alone. Even those new discoveries that we find, either they are counter examples to what has been known. I don't know which country, I think it's Australia with swans, and these swans were white until somebody traveled to New Zealand and found a black swan and then said, this is a counterexample. So this theorem, this hypothesis to say all swans are white has been countered by a counterexample. So there is an existing paradigm. It can be challenged by a counterexample, but no study stands alone. We can live all our lives, decades and decades and decades, and say humans can't fly until I spread out my hands and wings come out of me and I start flying. And that's a counterexample. Oh no, humans can fly. They were only supposed to present for 2 hours so that they gain their wings and then fly or drink Red Bull, gives you wings. So your task is to show how individual findings connect to a broader scientific conversation. Your literature review must be linked at all the times to what has been done by others. So here is the question. You are writing on HIV/AIDS. There are so many papers on HIV/AIDS in Botswana, in South Africa, in the United States. So how do you know, or why should you take the paper concerning Botswana and its context? Because it is related to what I want to talk about. So your task is to show how individual findings connect to a broader scientific conversation. Your individual findings, how do they connect to a broader scientific conversation? So you need to be able to compare methods to your experimental designs or your models. So by comparing approaches, you show awareness of the assumptions and limitations embedded in scientific practice. So the most dangerous illusion is when a student thinks that they found something new. And then like Archimedes, you jump and say, Eureka, I found it. Only to realize that it has been found a long time ago. We had a student with Prof. Farai the last 3 weeks, 4 weeks back. He came to the Department of Secretary and said, I want to see the HOD. And then I was there. I happened to be there. And he was like, I found a new way in mathematics of finding, what was he talking about? Finding it was not finding the limit, but he had a new way of finding pi. And I so happened to be there. I'm curious, obviously, another Isaac Newton bonnet UJ. So this is good news. So I tagged along because Prof was taking this student to his office and like, I can't miss discoveries because when the names are being written there, maybe then they will say the student's name, Farai and teacher's theorem. That's what I wanted to part of the bigger thing. And then when he started presenting his findings, we realized that it's not talked about much in mathematics, but it has been discovered a long time ago, and like centuries ago. And what he thought was new was actually an old classical theorem that they actually never wanted to use because of its complexity. So if you are not careful and if you don't read much so that you can link your work to literature, you are going to be overexcited over nothing. Let me use that word for a lack of a better word, because you will be talking about things that have been done by others. They've been done by others, and there is nothing new there. It's just that you found new vocabulary to say it, but it's not yours and it's not new. So you need to read much, and a literature review is based on extensive reading. So there is this debate that you can go and look at between Isaac Newton and Leibniz on who actually discovered calculus. And at one point in time, Isaac Newton then invited Leibniz to come to the UK, if I remember very well, so that they can try and have that discussion. So he was taking a home advantage there. But things have been discovered and never mentioned, locked ideas in the mind. So there are things that have been discovered a long, long time ago. And because of this writing now that is there, everything is on record somewhere. You just need to find it. So how then do you proceed? In that literature review, a body of work by others, where do you fit in? So position yourself as your study as a contribution. So as you write your literature review, it must be clear to us that you are fitting exactly here, because science progresses through bold conjectures tested against existing knowledge, and your contribution lies in how you extend, refine, or challenge what has come before. So you need to position yourself to say, this is where I stand. The mindset, well, you need to be critical. This is you now, the person you. Be very critical when you read other people's work. Open your eyes. And I remember at one point in time, we were gathered at this particular place, and then this person said, look, Prof, I saw that the parameter value that was used by this person on this paper, it was 0.5, but they didn't normalize that value. So is it still correct? But that work had been, it was already published, so it was already existing. It means that even though it's published work, still you need to look at it with a critical eye, an analytical mind, but again, look at everything with respect, respectful of prior work, people that have done this work before us. So today's knowledge rests on yesterday's efforts. If you find flaws in prior studies, the tone must remain respectful, because science is a collective, iterative endeavor. And remember, in our failures, we don't sulk, but rather we rise and say, look, this is what we found. It is not correct, but it is science and this is progress. All right. So we need to look at things from that perspective. All right. So now, what are we supposed to do? We are now done with our literature review. We talked about the introduction, literature review. Now the methodology. This is the engine. What we need is experimental and analytical clarity. Your method is the engine of your writing. So your thesis is mainly going to give results based on the methodology. So you now need a detailed account of your experimental setup, right? To say, this is what I am going to do. I'm going to start by collecting data from our world of data, and then analyze it or normalize it or remove missing data and do some data preparation. So you need to have a clear account of your experimental setup, your field methods, your simulations, and the instruments that you are going to use. So all relevant parameters, control, and replication details must be included. It must be that if I want to reproduce using your method, I can still reproduce the same results. So explain your choice of statistical analysis: justification, justification, justification. Every choice must be justified. Every assumption must be justified. You can't just choose. So you need to explain every choice of your statistical analysis and how you handled error reporting. And as you do that, we call for integrity. Be honest in your reporting, including any failed trials or unexpected anomalies. So as a scientific writer, your actions must reflect precision, responsibility, and a commitment to reproducibility. If in your method, the method that you are going to use, if you write it in such a way that you have shut us out, we are reading, we are learning, we are happy, and it's interesting, but at the same time, we are shut out because we can't reproduce your work, then we've got a serious problem. Be honest in your reporting. Include any failed trials. Include any anomalies. And because science is full of anomalies. That is a fact. There are so many anomalies, and we question those anomalies to say, why is this thing going in this direction? It goes our intuition to say it was supposed to be working in this way. So, what are the common scientific errors that writers make in natural sciences? Number one, you end up with an incomplete method. In other words, if you don't provide enough detail, others can't repeat your work. And this is a lack of methodological rigor. So when we mark your thesis, we just write lack methodology, lacks rigor, resubmit. Right? It's not as rough as I've put it, right? It's not as rough as I've put it. But I mean, if your methodology lacks rigor, you are going to find that certain examiners are going to ask for your code that led you to those results. Please give me your code, because you didn't include every detail that is essential for reproducibility of your work. And also selective reporting. It's a scientific error because you end up hiding failed experiments, and which actually creates biases, right? And misleading review of the research, because we are going to think that, okay, so if we go into the laboratory and we start mixing this in this test tube, then things are just going to turn out this way, of which you have been trying this for many, many days and it didn't work out. So you can't hide failed experiments. Obviously, sometimes it's because of funding issues and everything, but that is unethical. That is not allowed. So as you write your thesis, be cognizant of the fact that even failed experiments must be reported. And you can also have these statistical misuse. My learned colleagues here, during question time, they can also give examples of such. Incorrectly applying or reporting statistics can lead to false conclusions. And this is a form of p-hacking. We talked about p-hacking earlier on. And I can tell you that there are quite a number of people that are guilty of p-hacking. If we are to look at the reason why you are not proceeding, is because you tried to do a p-hack and your supervisor was quick to pick on it to say, okay, how did we get here? How did we get to this confidence interval itself? How did we get to this particular parameter value? So incorrectly application or reporting statistics leads to false conclusions, but then again the impact falls back on the supervisor as well, because we talked about joint what? Integrity. It's a joint responsibility between the student and the supervisor. So the idea that your work is irreproducible, it means that the scientific value of that work is compromised. Write your thesis, let's see it, but does it meet these criteria whereby we are able to reproduce your work? So how do you present results in natural sciences? There are so many methods. You can present trends, you can present statistical analysis and their significance. You can use things like visual tables, graphs, photos, spectra, and charts to make data understandable, or your results to be understandable. When we say data, sometimes it means results. What you need to avoid is clutter. putting a lot of information. Do you know that sometimes you can be excited to the extent that you do a PRCC test of a sensitivity analysis, then you get all these graphs, about 16 of them, because you were having 16 parameters, and then you now put them all in that thesis. Well, it's interesting you did this, but again, it creates a lot of clutter, and it sometimes even overshadows the real issues that we're trying to present. So avoid clutter, um, and focus on clear, interpretable outcomes. In other words, don't major on the minor. What is your mindset? Maintain objectivity and clarity in all your reporting. By reporting, we mean as you write this thesis, remember that it has to be clear, and also it needs to meet your objectives. So that is a mindset that you are supposed to be having. So as you present your results, what again are some of the scientific errors that we can find? We are going to find that people only present data that supports their hypothesis and ignoring unfavorable results. We talked about this. Failed experiments must also be, they must be reported. Otherwise, you are creating a form of a bias here that we've got. Then we've got misleading visuals, using deceptive scales or graphs or manipulating images to make effects seem more significant than they are. So I was talking to someone the day before yesterday saying, teacher, I'm having a problem here. The error, I'm using a population of 69 million people, but as I run my numerical methods thing, I'm getting an error of 900,000 people. Do you think that if I normalize my data, then this error becomes very small and then I'm good? Unlike using deceptive scales on graphs or manipulating images. That was me because I was preparing for this presentation. Like, are we not deceiving the masses out there, the scientific world? Are we not doing that? Because that compromises integrity. So at the end of the day, at every step, one needs to be very, very careful, not to cherry pick data, not to use misleading visuals, or to use complex or cluttered figures. They are confusing as well. So visuals that are too busy are hard to understand and can obscure the main point, which shows a lack of clarity. I think I talked about this. And then the most common error, presenting numbers without explaining what they mean, or figures. So most of the journals now, they say, make sure that you cite your figure in a paragraph somewhere. Instead of just like giving us figure 4, talk about figure 4 in some paragraph somewhere. Because if you present figures without explaining what they mean or their statistical significance, this leaves the reader to draw their own potentially wrong conclusions. And this is a failure of objective reporting. And once we have got the results, we got our discussion and our conclusion, which is scientific interpretation. Connect your results to your original research question and existing literature. This I know very well because you would collaborate. The first time I think I collaborated with some professors, I said, I'm done with the paper. And they said, do your results meet your objectives? I'm like, what? They say, read your results for us, please. And then please read your objectives. Are the objectives being answered by your results? It means that even though the results are there that actually meet the objectives, but if I fail to conclude, if I fail to discuss, that connection will never be found. So you need also to address any unexpected outcomes and anomalies, and also highlight your unique contribution, the study's limitations and directions for future research. Obviously, when I talk like this, people think that I'm about to finish. But let's move on. So, your mindset must balance confidence in your findings with intellectual humility. Be humble. Actually, this is one of the things that happens at the end of any study period, like 2 years of masters. being humble is actually a character that you must be having, because you'll be having boosted confidence because of your findings. But we need intellectual humility. Again, we need to understand that our supervisors, our professors, they are humans, they err, but at the same time, they know so much and they still have got so much to give. So as we write, as we say our results out there, still the humbleness is still needed. The worst mistake is to overstate conclusions, claiming your results proving something they don't. And this can be a failure to acknowledge the limitations of your study. All right? Or ignoring anomalies, pretending unexpected or contradictory results don't exist. Instead of hiding them, you should explain them. Tell us why it didn't work. You were expecting the graph to go up um, uh, because of what is known, what is standard. So why is it that it didn't happen in your case? All right. And obviously, as you do your discussion and conclusion, don't present your work as the end all be all of science in that topic. So again, you must be humble, present your work. Don't present your work as if it is the definitive last word, Isaac Newton kind of on that particular topic. Science is a continuous process. A good researcher always points to the next step. That's why when you write, you say future work. All right. And the worst mistake also is the strawman argument. What is the strawman argument? This is misrepresenting or oversimplifying the work of other scientists to make your own findings look more impressive. Unlike Isaac Newton, who said gravity is because of the two masses, our work is showing that there is more to gravity than, well, yeah, you are trying to rise in the scientific field by oversimplifying what the great Isaac Newton did. And this is a common and seriously ethical and intellectual error. I will give you this analogy before I finish. Everybody, as you start your journey, you've got two giants. You've got your supervisors. That's the first giant that you stand on. But as you stand on that giant, you need your paper that is provocative, that the one that has provoked you, so that you say, I'm now doing my study in this direction. When you do your literature review, all you are doing is standing on top of that giant and say, Chikore worked in this direction, but I can see the future. I can see that he didn't do that because I can see into the horizon, but my sight is based on the fact that I'm standing on top of a giant. So you need to understand that your work is based on what has been done by others. So oversimplifying the work of other scientists to make your own findings look more impressive, it's just unethical. Let me say grossly and seriously unethical. And it's an intellectual error. So let me finish by also mentioning the discussion errors, this discussion and conclusion errors, by mentioning that some people, most of the people, actually believe that correlation means causation, which is a fundamental statistical error. There is causation that we can actually measure by using the Granger causality, but correlation is just measuring how things are related. As this goes up, then this also responds by going up, positive correlation. So a strong discussion will use cautious language to describe relationships. It's very, very important to choose your words carefully. Let me finish by saying, as I bring it all together, the science and the mindset. The success in this business requires the candidate who owns the work, who is curious, who is persistent, supervisor who is guiding and helps with critiquing of the work, timing, planning, flexibility, your state of mind. Things are going to happen. People get pregnant. Our relatives, our beloved die. but we are going to remain focused because we have got 4 years that we have been given for PhD, 2 years for masters. A lot is going to happen that will affect our state of mind, and the relationship between the supervisor and the other collaborators also can be a bit cranky sometimes. That's okay, but our state of mind must be of focus, resilience, and motivation. I am learning, I'm tapping from the greater giants, and that's what I'm going to do. Your structure of the thesis must be clear and must be reproducible. Iterative learning, experiments may fail, drafts improve, but the mindset matters. That's all that matters. Your mind, as you do this, you should know that you're a scientist, and my mind is that of a scientist, and I'm going to write like a scientist. Thank you, guys. Thank you, everybody. I'm now taking questions, and I know that I've got learned experts that can help me with this.
Thank you very much, Dr. Chikore, for that insightful presentation. We already have some hands that are going up. I don't know if it's okay. I see they're going up and then down, so I'm not sure if people actually raising their hands. But yes, thank you so much for not only outlining the thesis structure in the natural sciences, but for also giving advice on, outlining the challenges that one faces and also assisting us in terms of, how we can overcome those challenges. And as you were mentioning those challenges, there's a comment that came through from Komodo, and it says, Doc, why are you talking about me? That actually shows how much most of the people actually who are in this workshop can relate to those challenges. And again, thank you for, just assisting us to, find ways of dealing with these challenges, because the thesis writing it's not an easy journey. And that's why sometimes we need, you know, people like you to come and, give some insights to help us navigate this journey. So thank you so much for that, and also for outlining, the relationship between the supervisor and the student, and the responsibilities that comes with the supervisor and the student. I think it's important for us to know that as well as we are navigating this journey, and also some of the helpful software tools that you shared for time management. You spoke about the Gantt chart, and while you were speaking about the Gantt chart as well, there's a comment that came through from Pilisiwe, that says, can you post the link for the Gantt chart software tool on the chat? If you could share the link for that, if possible, on the chats. And thank you so much. I will now open the floor, sorry, for questions, and I will just enable everybody's mic so that you can just unmute yourself and speak. So let me just quickly 1 minute as I change the settings to allow everybody's mic to be enabled, and so that the questions can be asked easily. Those who want to ask questions, you can just unmute yourself. There we go. You can just unmute yourself and ask a question. And there are already some comments that are coming through. Says from Emmanuel, thank you, Doctor. From Sipogazi, thank you, Doc, and wow. And also from Akiwale says, thanks so much, Doctor. And Patel says, beautifully presented, high energy, clear and engaging. And Patience says, thank you very much. And Emmanuel also says, can we have these details in our email? Okay, we will share the presentation slides. Can I please request also, Dr. Chigora, that you share the presentation with me so that I can also share with those who have joined? As Zingle says, thank you, Dr. Tichauna. And Megan says, thank you, Doc, for the timely presentation. Could you please throw some light on thesis by article, as well as its pros and cons? Thank you. That's one of the questions. If you could please throw some lights on thesis by article, as well as its pros and cons.
So what I'm going to do here, obviously I have to stop sharing here. So what I'm going to do is, I'm sure that Prof, there are some people here that can actually explain the position, or especially of the department in the Faculty of Science, concerning a thesis by publication and then by uh, thesis by articles, and then the standard thesis that we know. So I don't know, is there any professor that can help us?
Can I just come in, maybe?
Thank you, Prof.
Yeah. You know, it's not difficult to explain the difference between the two. The major difference is simply the fact that if you choose to do a thesis by publications, it simply means that you have to have the prerequisite number of publications, which you simply put together as a thesis, and nothing more. So it is simply, papers that are just put together to form a thesis. Whilst when you look at the other normal thesis, this is where you have to write an introductory chapter, followed by some kind of literature review, depending on your domain. You then go and look at a third chapter, a fourth chapter, whatever it may be, and the requirement there is you must have published, you know, if you publish one article, you can put together a thesis, and that will qualify that you have you will graduate, provided you have another paper that is camera ready. But when it comes to thesis by publication, it simply means that you need to have a prerequisite number of publications that you can put together as a thesis. I'm not so sure how many you would require, but these are simply publications that are basically put together. You may not you just need to find a way of just connecting them together, but they are simply papers that are put together to form a thesis. While it's on the other hand, you have to follow the normal thesis structure as the presenter was describing. Thank you so much.
Thank you so much, Prof. Nyabaza. I hope the person who asked this question has been answered. Thank you for that explanation and for the clarity as well. So we have here, there's a comment from Maureen as well that says, okay, the questions are more. Okay, if you could share your email address. I see Dr. Chigora has already shared the email address, and there's also a question from Messi, which says, when you copy a known formula from a book or WhatsApp, that is difficult to type, hence you just post it into your document. It should be cited. Is it plagiarism? And some formulas are hard to type them yourself. So should it be cited? Or is this plagiarism if you just copy and paste a formula from a book into your own document? That is a question from Missy.
I recognize Prof. Chiroe. Okay, I see Prof. Chiroe is not there. So to answer this question to the best of my knowledge, because the question of plagiarism is a very, very important question. That's why I also said in my presentation, it's very, very important for students to attend specialist presentations on writing the introduction, on writing the literature review itself, the actual act of writing. But now there is a WhatsApp message, I don't know, from a friend or something, and this is an issue of convenience. that the person, it's Messi. Messi is asking on the question of convenience to say, is it okay if I can just copy and paste it? It's a commonly known formula. So what is going to happen is, number one, you are going to just have helped yourself saving time. The idea of plagiarism comes into copying formulas that were used in other papers without citing them to say, according to the work that was done by Chikore, then you put the reference. This process evolves using the following mathematical formula, and then you now put that formula in there, but you've already cited the authors, the original authors of the work. So there is an issue of just being having a convenience of like, you know what, I can't type this, but then you just paste it from somewhere. But in the case of it belonging to someone, then it becomes a different ballgame. So you are going to find that there are common mathematical formulas, like what has been said, that you don't need to cite. You can cite also depending on the audience, just to guide your readers to say, look, when we talk about this I know you're aviation readers, you're not mathematicians, but if you want to know more about Euclidean mathematics, then go to this source. But Euclidean mathematics is common mathematics. So yes, so if you extract someone's work, cite it. But if it is just because you are doing it for convenience, then that's, to me, I would say that's okay. But again, this is evaluated on a case by case basis. That is to the best of my knowledge. I don't know if somebody can also assist. Other professors that can help.
Maybe I can come in again. I was actually wondering what kind of a formula would be very difficult to type, especially with the current technologies. You know, these things of getting formulas typed and whatever shouldn't actually be an issue. But if you just copy something from somewhere and you paste it into your work, for me, it borders very close to plagiarism in the sense that you are simply taking what somebody did and you are placing it as though it were your own. I have had these instances where people, they don't want to do any simulations, they just go and crop a graph and then they paste it in their work, and then they don't acknowledge where the source of that particular information is. Then that is basically plagiarism in a way, especially taking work that you definitely know that this is not of your own and you present it as your own. Then that is very, very, very serious. So I do agree, but with mathematical formulas, hey guys, we should just type. It shouldn't take any I mean, with the current technologies, to say I failed to type, it would be just, but I don't know. I wouldn't forgive anybody. Should I be marking your work? Thank you.
Okay, thank you, Prof. Nyabaza and Prof. Chikora, Dr. Chikora, for answering that question. I hope you've been answered, Missy. And Mpo, you may go ahead.
Good morning, everyone. Thank you, Prof, for a wonderful presentation. It was quite interesting. Just want to ask, in terms of publishing, let's say you published some of your work, when coming to writing a thesis, is it fine if you like put it the way it is, or do you have to paraphrase?
I will be honest with you. We have had 3, 4, 5 experiences with this. Is Dr. Gachen here? I saw her earlier on. Then she can actually respond to this from her own experience. Dr. Spokazi? Prof, how did you handle all these situations, the one of Dr. Spokazi and the other people that we can mention here? Okay, let me answer to the. So this is not a new issue. This is something that actually happened, and that is happening year in and year out. Um, when you have written your chapter 1, which is the introduction, then you write your literature review, you've cited, everything is okay. But then there are these publications that are going to be part of your work. When you are submitting your work, part of the requirements, especially at the University of Johannesburg, is you must have your Turn-it-in report. Your Turn-it-in report, and boom, it goes all the way to 87. And that is because chapter 3 is your publication. Maybe chapter 4 is another publication. So now the question that is being asked is like, how do you remove those publications? Then you do turn it in for the work without those publications. And I'm just trying to find out how Prof went around it last year and the other years. Prof, if you're saying anything, you're on mute.
No, it's actually, yeah, that's, to be honest with you, that's usually a tricky thing, and usually it depends on certainly the agreements also between you and your supervisor. Usually when it comes to the Turn-it-in thing, you definitely know that this result is already out there in the public domain. So putting it again on your Turn-it-in report or your Turn-it-in platform, then you definitely know you're going to be accused of self-plagiarism in the process. So it is always important to usually to just exclude those particular sections which are already there. We know this is your work, and it is already published. It is out there, and usually there are times when we have accepted reports with some higher Turn-it-in percentages as a result of acknowledging the fact that we are simply, whatever is being reported is exactly part of your work. I know some people ask for paraphrasing. It is okay if you have the time, but I have to be honest with you, many times it eats into quite a lot of your time, because you have to paraphrase, imagine the whole article. That's usually quite a very difficult thing. But I know there have been debates around issues of self-plagiarism. And of course, the debate has been, it can't be self-plagiarism it can't be plagiarism if if I'm simply giving you out again the very work that I did, which simply means I didn't plagiarize, but according to the systems, yes, it brought us around that. So it's usually a tricky thing, but sometimes it's something that can be handled again on a case by case basis. Yeah. Thank you so much, teacher.
All right, Prof.
Okay, thank you. There's another question from Tumelo, which says, thank you for a lovely presentation, Dr. T. What can one do as a researcher who tried to reproduce a certain method or procedure but gives different results? In short, the research is not reproducible.
Now, the issue of reproducibility, at the end of the day, if it is not reproducible, it's either an issue of clarity in the methodology to say, and which is true about most authors. There are some statements that we write at the end of every article to say data availability. Then some people will say data are available on request, on reasonable request, or data is available in the public repository, or data on this in this work is not even available. So you are going to find challenges with things like, you also want to protect your work, because when you write your article or when you write your work down, your scientific work down, you are going to it is going to be sent out there for review by others. But one also wants to be careful to protect themselves, to say, look, That's why there are preprints actually. Preprints are to make sure it's a form of security to say I've secured that this is my work. So most of the times people might end up hiding things like data to say you can only get data from me on by if you make a request. The reason that is because you're trying to protect your work. So reproducibility is something that is there, but I think it goes with working together even with the authors of that work to say, let's talk about how you got here. And at the end of the day, they will tell you that, no, wait, yes, we've got enough information in our methodology, but also there are these 2, 3, 4 things that we can give to you that we use to get to this point. I remember when I was working with someone in geochemistry, we were looking at this data and he was trying to produce this graph. So that was my role in there. I'm not a geochemist, but my role was to try and reproduce the graph that was in another paper. And I was doing it in Python, and those people, they did it in R. So the fact that we actually came up with the graph, just that it was a bit different. And it was like, but it's not the same. And they said, it's because now the tools that we are using, we are working in Python, we should expect to get a slightly different graph. But if you try to interpret it, you're still going to get the same result. So most of the authors, they might not specify the packages they used in R, even sometimes the software they used, of which they must actually say, we did this work in MATLAB. So at the end of the day, it's all about the details that might not be sufficient for you to reproduce, but if you engage with those authors, you will get something that can be reproduced, or you will be able to reproduce the work. That's what I think there.
Okay, thank you. And we have sorry, Tanya, was you going to add?
Yeah, sorry, I just wanted to say I had some experience of somebody in India who was trying to do part of some work that I did, and the person was failing to reproduce the work. And then he had to write to me to say, this is, I'm trying to reproduce your work. Is there anything that I'm doing wrong for me to not to get the result? So I had to take him through whatever I did. But I just wanted to throw some caution into this wind, that we need to understand that as far as research is concerned, I have to be honest with you, there are some people that do take shortcuts, and reproducing their work might actually be very difficult. I know in some sectors it is actually very, very difficult to reproduce one's work, but those things do happen. Thank you so much.
Okay, thank you. Thank you so much for the clarity. Untatile says, thank you for the presentation. Could we kindly have the recording? Of course, we will share the recording. Pilisi says, will I not have plagiarism issues at the end when I compile the final thesis containing the published articles?
Oh yes, so that's what we mentioned earlier on, that you are definitely going to get an 82% of plagiarism. Unfortunately, when things or your documents proceed up to the higher degrees committee, they only look at the 82% without the explanation. So like what Prof was suggesting earlier on, that rather it's a discussion between the supervisor and the student to say, let's take these ones out, let's run everything, because the plagiarism will be identified through your introduction in the thesis. So one of the things you're going to learn is that your work, your manuscript, the work that you are doing, the topic you're working on, the paper that you submitted for publication, you are going to, it's going to have its own introduction, its own small literature review, but your thesis has got a section, a chapter called literature review, where you now explain, expurgate, and extract and do any other axis that you can do there in talking about the literature that you would have used. So it is that introduction and that literature review and your discussion and conclusion that matter mostly to go through the Turnitin report, so that when you generate that and there are still elements of plagiarism more than 20% at UJ, then you need to work on that. Otherwise, like what Prof said, definitely you are going to get plagiarism from your work because it's already published. So it's that, depending on the relationship between you and the supervisor, the department policy, how they treat such matters, but it boils down to a specific case to say this is what the student is facing. And remember, when all this is happening, you are not facing it alone. Why I brought Prof. Farah, no, I didn't bring Prof. Farah, but why Prof. Farah is helping me with answering some of these questions is we experienced this. We saw all these things happening. And at one time I was his student and he helped. I was not alone. So you will never be overwhelmed to say, now I've got 82% plagiarism. What am I going to do? I don't know now. My life is finished or something like that. It's not. You still have your supervisor. You are going to come up with a plan.
Thank you for that, Dr. Chikore. And Komodo on the comment section says, overleaf is my fighter. Komodo, would you like to share? I understand that maybe this is a software tool that you can use. Do you mind sharing? Maybe some of the students will also want to know it and use it. So apologies for giving you the spotlight, but would you like to just explain what this software tool is used for and how can the other students use it, just to share some tips? I mean, these workshops will be useful also if we can, assist each other with some of the software tools that we use for our research. So would you like to maybe explain a bit on the overleaf, Komodo? Or maybe you can just type on the chat box if you don't want to unmute.
Good morning, everyone. Good day, everyone.
Hi.
Thanks, Doc. Thanks, Dr. Teach, for the workshop. I had to make time for this one. Thanks a lot. You've shared a lot of insights. Well, that comment was a response to what Prof. Nyabata was saying about having to type formulas, the new technologies that we have. So overleaf LaTeX is one of those that you can type complex mathematical formulas. So I was just adding it to the comment as I was speaking about these softwares that we can use to type formulas, because sometimes when you type on Microsoft Word, it cannot handle large formulas, but with overleaf, you definitely can type your formulas there.
Thank you, Komoto, for pointing that one out. And I think, Prof, it goes back to the discussion we were having the other day to say maybe the department, maybe the faculty might want to consider embedding things like especially overleaf as part of the curriculum, so that when students go to postgrad studies, they don't need to encounter or LaTeX and start from there at honors level or something like that.
Thank you so much, and thank you, Komodo, for sharing that information. For those who did not know the overleaf, they will then explore it and just start to use it. Thank you for sharing that. We truly appreciate it. And the last comment on the comment section is from Emmanuel, and the comment says, "What will you do if your supervisor said he is not going to supervise again?"
So it's not really clear. We are going to try and answer this from all perspectives, so that we don't put Emmanuel in the spotlight. So what will you do if your supervisor said he's not going to supervise you again, or supervise students again, or something like that. Obviously, one of the things that you learn as you go in this journey, that's why we talked about the state of mind, the focus, the resilience, is that sometimes your issues, they like issues, I'm talking about life issues, sometimes they also need space in this master's thing. They also need space in this PhD thing. And Prof can tell us about it's a term that is it abeyance, I think, whereby sometimes when you're in a tight spot, you might need to take some time out. So Prof knows how that process works, but timeout might be needed because of the social pressures. Exactly, there can be social pressures that can actually put you in a spotlight. But this being the last question, let me finish by thanking everybody that attended and said, guys, thank you so much. I am not as old as my voice sounds, but I'm really impressed by all your comments. And thank you very much. So Prof, I don't know if you want to talk about abeyance and how it works that can help people take a break.
Um, I hope you can hear me.
Yes, we can.
So that at least you can say I am pausing my studies between this period and that period, and then as a result you are not charged school fees. But if you want to go, if you take abeyance in the middle of the year when the fees have already been charged, then you are still liable to those particular fees. So it is simply a way of saying if I'm under pressure, I can just take a small little break without me not being affected in terms of my time to completion and all those other things. So it is an application that you actually send through to the faculty that needs the approval of the dean for you to take that particular break. It simply means you also take a break from paying fees, you also take a break from your studies, and it is not counted in your the number of years that you're expected to complete the qualification, but it is simply a pause in your studies. Thank you so much.
Thank you. Thank you so much. There are no more questions on the chat, and I don't see any hands that are still up. So I will take this opportunity to thank you, Prof. Chikore, for availing yourself and coming to present at this workshop. Okay, I see there's a hand from Macy.
Yes.
Before I close, I'll allow Macy to ask the question. Macy, you may go ahead. Missy, we can't hear you. We see that your mic is unmuted, but we can't hear you. Would you rather type your question on the chat box because we can't hear you. Okay, while we're still waiting for Macy to ask the question, to type the question in the chat box because we cannot hear her at all. Let me just take this opportunity to remind everyone to complete the feedback survey. There's a feedback survey that has been posted on the chat. Please, can you take a few minutes to complete the feedback so that you can give us some information on how the workshop was and some insights on some of the things that we can improve on our workshops in future, and also to take this opportunity to suggest some of the workshops that you would want us, or the topics that you would want us to cover, and we will do so. Macy, we're still waiting for your question before I can close. Okay, there we go. We have a question from Messi on the chat. It says, so whatever you are going, so whenever you are going to register for a carousel for us online masters, does it mean you should tell the faculty?
Prof? I refer to Prof because he's also the HOD for our department, so he knows these protocols better. And it's always good to give correct information.
Yes, definitely. I wonder if Prof is still here.
If he's there, then he's on mute. But it's fine. Since Miss, you got my email address, you can just write to me and then we will make a follow-up on this particular question.
Okay. Prof. Chikora did give his email address on the chat. Missy, please can you take the email address and send him an email for further communication and clarity regarding this matter. Thank you so much. And let me take this opportunity to thank everyone that has joined us today for availing yourself to join the workshop and for your engagement during these workshops, because these workshops will not be engaging or without your participation. So we truly thank you for taking the time to support us in attending our workshops. And thank you, Dr. Chigore, for availing yourself and honoring our invitation when we approached you to come and present this workshop. Thank you for agreeing to do the workshop and facilitating such insightful and informative workshop. We truly appreciate it. And I will again remind you to please share the presentation with me so I can share with those who have attended. And in the beginning, there was a question, a request for you to share the link for the Chant software app that the Chant chat that you shared. But I saw that you have embedded the link on the presentation slide. So if you are not able to share it on the chat, I will definitely share the presentation and they will use the link on the presentation slides. Thank you very much. If there are no more further questions or comments, then we will close the workshop and wish everybody a wonderful day further. Thank you for joining us today.
Thank you very much.